Hey, good evening, everyone, or good afternoon. I'm Nicolas. Thanks for Neo4j for the opportunity to do this talk today, which is about architecture, the difficulty of doing microservices, and how graphs can help to identify and fix some problems in this context. So, a quick introduction. I'm working at GraphAware doing some development, training, and consultancy to build things like fraud detection, knowledge management, or recommendation engines. And besides that, I'm also a co-author of the book A Graph Project Story, which is available on Amazon, advisor at Biber, and sometimes I organize some Neo4j meetups. So to give you a bit of context about these talks, a few years back, I was asked to work with a client who decided to basically rewrite all his IT system using microservices. And the actual benefits were not meeting the expectations. That there were plenty of issues, they were experiencing lots of bugs, had regression during the QA phase, problems were detected very late in the cycle, so it was quite painful. Yet the teams on site were very involved about quality, and they tried to improve the situation with code reviews, refactoring sessions, and so on. But the situation did not seem to improve very much, because the system was already quite big, with more than 30 microservices in production, and it was difficult to get an overview and to know where to act, actually. So this illustrates the fact that not everybody can be Spotify or Netflix, and people don't realize how difficult it is to switch from a traditional approach to microservices architecture, and how it's difficult. It requires really a lot of effort. And it has been discussed with many people in different talks and blog posts, such as the 7 deadly sins of microservices. And it's easy to get lost on the way. And when you discover problems too late, then you have tens of thousands lines of code in production. And actually, you cannot fix everything. You need to have a very clear vision of the situation and prioritize what you want to do. So I wanted to share today how graphs help me doing this. So after a bit of research, I came across a great tool called jQAssistant, which allowed me to transform code into a graph in Neo4j. Because the code actually is a graph. And not only the code, the software architecture and all the rules that go with it is also a graph. So I figured out that creating a graph was helpful to do different things, like detect antipatterns in the development, do some impact analysis, improve data governance or communication between teams. So I'm going to go a bit more in detail about that. During the talk, we'll go through examples around these themes, and for this, we'll use Piggy Metrics. So Piggy Metrics is a personal finance example application. It's a kind of blueprint application demonstrating the use of microservices. It is developed with Spring Boot and Spring Cloud, and it uses based on MongoDB database. So the transformation of this application into a graph is very straightforward. We just have to provide the jars files, so we need to build the application, and then need to provide the jar files to JQAssistant through the command line, as in the example. And then a few seconds later, you have a graph. It's very easy. And from code that looks like this, so in this example, we have a user controller. Well, this is a class taken from the Piggy Metrics application, user controller. it's a standard Spring application, and a standard Spring REST controller. And for those who are not familiar with Spring, it defines two methods named getUser and createUser, and those two methods are exposed through the green request mapping annotations. So inside those annotations, we find some URL PCs and HTTP verbs that are mapped on, and we can see that we have a call to the user service. So this controller as a graph looks like this. We can see that the different pieces of the code are represented through nodes and relationships. We can see, for example, on the left, the red node represents the jar file, and it's linked to our blue user controller class through a contains relationship. And our controller class itself is linked to our getUser and createUser methods that further invoke other methods. So, and of course, the annotation we saw before, the request mappings, are also present in the graph in green, and along with their parameters and so on. And that's very cool, this kind of thing, because only with this we can, and with very few effort, we can do a lot of things, like checking for coding rules or architecture rules, see if they are followed or not. For example, this allows to detect cyclic dependencies between classes or modules. It allows to detect if some code is covered by tests, if some naming conventions are followed, and so on. So out of the box, you can do a lot of things. But okay, I already hear some of you say, but my microservices are loosely coupled. They communicate through HTTP or asynchronous protocols through message brokers and so on. And this actual type of communication is not reflected into the bytecode. So you're right, but we can use our graph representing the code as a basis and build on top of it. Above languages and frameworks, we have higher level concepts in our applications, software architecture concepts, and it's also possible to materialize this higher level concept in the graph. Things like API or different engineering practices. So let's go through some examples of that. So an example of this, well, let's go back to our user controller we've seen before. As we use the Spring framework, we can traverse the graph to identify the methods with the right annotations, some URL mappings, and some HTTP verbs associated with them. And this is what the Cypher query on screen does. It looks through methods annotated with request mapping annotations and gets also HTTP information into the graph. And it enriches the graph with a new concept, the concept of endpoint. So next to the blue arrow on the left of the screen, we do some set instructions that add the endpoint label to what we found and add the HTTP mapping information to some method nodes that we know are exposed as REST endpoints. So yeah, let me just go back. So for example here, we are defining some REST endpoints that match the two methods we've seen before. So our getUser and createUser under different paths. So these are the light blue nodes. In the same way as with endpoints, we can also define some concepts about the HTTP client. on our pgmetrics application uses the feign library to do its HTTP call between a service and another. And so we can use it and go through the graph to create a new concept by looking for the feign client annotation and its related information. So exactly as for the controller that exposes some REST endpoints, here we have the HTTP client that call URLs through HTTP verbs. And we add this new feign client concept to the graph through the feign client label and with some URL information. The obvious next step, once we have identified the HTTP clients and the REST endpoint they call, is to link them by matching the URLs and the HTTP methods they use. And this is now really easy to do thanks to our new concepts. And for example, here, I decided to materialize these calls in the graph through a relationship called invokes remote. So we're looking at the clients and the endpoints and match the URLs and the methods, and then link the ones that have to be linked together. And from there, what we can do is very interesting, because now we can determine cross-service dependencies, something that is not easy to do from scratch, because our services are loosely coupled. Now, these loosely coupled things become apparent in the graph. And this is what it is on the picture here. We can see our 4 services we injected before and how they call each other. And with that, we can find antipatterns, such as loops between the services that cause some chicken and eggs problems. Or we can do impact analysis to determine, for example, let's say how hard it would be to change a specific endpoint. So if it's heavily called everywhere in the system, either directly or transitively, we can know it. And that's very cool. So with our graph, we can go even further to estimate a kind of maturity level of our services and check if they respect best practices we defined, such as, for example, the good practice is to use isolated database, or do they have some documentation, or do I have a resilient system? So let's go through some example of that. Our pgmetrics application is based on MongoDB and Spring Data MongoDB. We can easily define a persistence entity concept. So I didn't show it here, but it works exactly the same as before. And with this kind of information, we can, for example, check the usage of MongoDB collections across services. And by running this query, we can see that the account collection is used by 2 different services. So maybe it's a legitimate use case, but also it can be a sign, and it can reveal it's a bad isolation between those 2 services, and maybe those 2 services should be merged. So this is really interesting to see some database that is managed in several places at a time. In the same way, we can also define the database repository concept to determine which endpoints are directly or transitively impacted by a repository change. In the example here, the user repository at the bottom of the table seems to be used transitively by a remote service. So if we want to change it, then we may need to check the impact on this remote service. That is not obvious when we just look at the code of this single service to which this repository belongs. Just a word here about databases and relational databases specifically, because a cool thing JQ Assistant does is to scan the database metadata through JDBC, and it can put the database structure into the graph. And it means that we can do even more advanced analysis than with MongoDB by doing impact analysis even down to the column level if you want to let's say, validate, for example, if we want to change the data format or the length of a column into the database, identify all the objects that are linked to this column. Another best practice in the microservice world is to have a contract-first approach by beforehand defining the specification of the API and then proceeding with the implementation. And we can do that, for example, with the Open API specification, which is the industry standard now, and write your API contract using YAML files. But then you may have a problem. How can you know that your specification or your documentation is up to date with your implementation? And luckily, we can also scan YAML files and easily find the Open API description into the content of the YAML files. And that query, what it does is just go through all YAML files and look up for keys named Open API and check if every service has at least one specification file. So this can be a quick way to identify a lack of documentation. We can even, in terms of documentation, deep dive further into the documentation contents. For example, extract parameter names, types, and so on. We can do the same things with the Spring controllers and then compare the two to actually detect gaps. Here we see, in this example, I omitted the query, but it's not that complicated. I have the examples on the GitHub repo I'll share later. We can quickly see that there is some documentation missing for one service here. We have only 2 endpoints out of the 3 that are actually documented. And we can go down to really the parameter of the API and go down to the types even of the parameters. Resilience is a very important topic because failures will happen in production and you need to take it into account to avoid your whole system to collapse. And there are well-known mechanisms like circuit breakers and response fallbacks to avoid cascading the failures to upper level services. And in our case, if we wanted to check that fallbacks are correctly implemented in all our endpoints or HTTP clients in this case, we would use this quite simple query to do that, going again through annotation, the faint client annotation, and see if they have some attribute declaring a fallback. And in our example, our PD metric example, we can see that there are 2 fallbacks missing in some services. What we can also do is some nice visualization. Because what the advantage of having an open graph database is that you can do selective export of this graph and then export them as GraphML files. And once you have GraphML files, it's very easy to import this and visualize your exported data in tools like Wired. Then from Wired, you can apply some like styling, do some layouting. And if you have a large number of elements, then this can be very useful. So I won't go too much into the details, but you can export many different shapes of your architecture data. Here we have a simple example of dependencies between the services, but we can change it to the level we want to export ad hoc visualization. And this can be really, really useful. In a real world, just to give an idea of how it would look like on a real system, here's an example. And I found this visualization were a super useful tool for team communication. And at first between developers to better understand what needs to be done and with architects, but also sometimes it allows more efficient conversations with product owners or project managers. The fact of having some kind of truth that is really exported from what's really running gives a high trust level on this kind of diagram. And I'd like to mention that this is really, really hard to get this done manually. I've seen actually someone working for weeks on that, trying to build this by hand and keep it in sync because the whole system was evolving all the time, and for him, it was a nightmare. So we've seen some examples of what we can do and how we can use a graph to identify some issues, but there are a lot more that can be done. For example, we could dive deeper into security problems through dependencies or look for some annotations that are supposed to be on the endpoints to secure them. We could import some runtime data to, let's say, have an idea about how many calls are done on an API per day and give compute some kind of importance of that API. We could import data from version control to prioritize the fixes according to the dependency of changes into the source code. Of course, if a service is rarely modified, then probably means that it's working okay. So we don't want to touch it, right? And we can do much, much more. A really cool thing would be to be able to scan the front-end side application, for example, a JavaScript application, and be able to do impact analysis all the way from the database up to the UI. So this is something I was looking for, but I didn't find yet a way to ingest some JavaScript application into Neo4j. But maybe if you guys have some ideas, I'd be happy to hear about that. So from a jQAssistant perspective, I've been focusing the talk more on architecture analysis than features out of the box available into jQAssistant, but we just scratched the surface of what this tool can do. It's really cool. It has a lot of plugins, over 30 plugins that you can use to scan source code control, spreadsheets, XML, whatever, many things. It can produce some nice reports. It can be integrated into the delivery pipelines and talk with tools like Jenkins or SonarQube, push some alerts. And everything I showed you today can be written as executable specifications. And that means that those checks can be automated. So there's a friendly way of expressing your concept and your constraints you want to check into jQAssistant. And you can automate all this in a very easy way. And you'll find some example of this into the GitHub repository, where I put the code samples. So I'll post it on the Q&A section later. So I really invite you to check it out. It's really a nice thing to do. So in the source code repository, example source code repository, you'll find a kind of tutorial or a step-by-step approach, a bit more detailed than we covered here, but taking back the same points we talked about. And that's it as a conclusion. I hope that I convinced you that according to your needs, according to your architecture, then you can build a graph reflecting higher level concept than just basic source code. And from there, you can have a real-time, up-to-date knowledge of your running system. And you can check how this reality matches with your initial plans, and maybe do some review or some compromises or some adaptations to your actual architecture rules, or decide to act on specific things on that. Thank you, and yeah, don't forget about, let's go for the Q&A, and don't forget about the Hunger Games that are available. So we have a few questions here. So
thanks a lot, Nicolas. So I think I can read some questions to you. So first question is, John asks, I'm doing something similar through bytecode analysis, and we have difficulty sometimes determining the URL for connecting service to service, because the URLs are deeply embedded and sometimes in property files and so on. And is there something special you do to get these connections?
yeah, I didn't detail that, but in the example and in the repository, this is exactly what's done, because we have parts of the URL that is declared at the method level, some part at the URL declared at the class level, and pieces of the URLs that live in configuration files. And what we can do, as jQAssistant is able to parse properties file, we can always find a way to get these properties somewhere and connect them together. So there's an example of that, of this like kind of multi-stage assembly of URL pieces to have to something that is correspond to the real URL.
Okay, thank you. A bunch of people asked about code in the repository, and if you have forgotten to push it because it's currently has only a license file in there and nothing else.
Sorry, I didn't get the question.
So the question was, currently there is no code in the repository. It's only a license file. So did you mean to push it and didn't get to it, or?
Oh yeah. Sorry, I forgot about that. I will push it as soon as the talk is finished.
Okay,
it's
thanks.
Nearly ready. It will be there in like 10 minutes.
Thank you. And the other question is from Benjamin. How would you apply this to generic microservices when you have no Spring or Feign or things like that?
I'd say that, okay, even if you don't have any Spring or Feign, you still try to keep some standards in your code, because you don't want to have a different approach for every call you do. So you can probably from that define some concept that match that match your code, and still be able to define the same concept based on different way of computing them. But this is I didn't come across to something that is not achievable, unless you're really doing different things every time you do a call or like that. You may have to build some, maybe 2 or 3 different approaches to build the concept, or 2 or 3 different queries, but I guess it won't be more than that.
Yeah, so in general, JQA has the ability to match any kind of patterns in source code. So it could be something like annotations, or it could be like naming patterns or similar things, even packages or routing files or things like that. So you could use any kind of way to determine this. And what you can actually do in JQA in general, what Nicola also showed, is that you can basically create a higher level language that kind of doesn't talk about classes and annotations anymore, but talks about endpoints, for instance, in this case, right? So you kind of create a higher level architectural language that talks about the things that you want to actually query.
Right? I know we didn't have anything in the Q&A.
Thank you all,
itself, I don't think,
thank you, Nicola.
If you have
was
questions,
really good.
you could just type them right in.
Thank you very much. And yeah, check it out.
Bye-bye.
Bye-bye.
An opportunity of Andrew being here to answer it.